Alright, in this video we're going to graph two parabolas that are in vertex form and just kind of go through the steps that we did in class. So the first, we're going to go ahead and write what vertex form looks like. It's going to be a times x minus h squared plus k. And your vertex is going to be h comma k. Notice that the h will be kind of the opposite. So instead of minus 3 there, we're going to use positive 3. That's where it's going to be zeroed out. So our vertex for this particular graph is 3, and then the k is always the same. So 3 and minus 4. Okay, then we'll go ahead and do our number system. And then we'll go ahead and plot our vertex. And because the a is positive, you don't see it, but it's a 1. The 1 in front of the x minus 3 squared is positive, so it's going to open up. The axis of symmetry is always going to be x equals h. So it's just the x coordinate of the vertex, so x equals 3. And what we're going to do is we're just going to draw that as a dotted line. We're going to go ahead and construct our table, and what we'll do is, since it's going to be symmetric at the axis of symmetry or at the vertex, we're going to pick some points around 3 on the x-axis. So we would have 2 and 4. So 2 and 4. Here's 2 and here's 4. So those are the 2 points we're going to pick, and we're going to plug them into our formula. So if we plug 2 into our formula, okay, 2 minus 3 is negative 1, and negative 1 squared is 1, and then we'll subtract 4, and that's going to give us negative 3. And similarly, if we plug 4 in, 4 minus 3 is 1, 1 squared is 1, minus 4 is also minus 3. So we have 2 symmetric points there. Okay. Then we're going to play the same game. We're going to go to the left and right one more time, and we have 1 and 5. And we're going to plug those into our formula. So 1 minus 3 is negative 2, and then we square that, we get 4. Then 4 minus 4 is 0. Same thing what happens when we plug 5 into our formula. That's going to give us 2 points, and those happen to be our x-intercepts. We don't always get our x-intercepts this way, and we'll go ahead and talk about how we find our x-intercepts in just a moment here. Alright, we're going to go ahead and figure out what the x-intercept is. So if we're on the x-axis, all the y values are going to be 0. So we're going to plug in y equals 0. And then solve. Well, we don't have a y in our formula up here, but f of x is the same thing as y. Okay. So if we're looking for the x-intercept, the y is equal to 0. So we're going to replace f of x with 0. And you folks have been getting real good at solving these equations using what's called the, I think your book calls it the square root method. So we're going to isolate the squared term, the x minus 3, quantity squared. So we're going to add 4 to both sides. And then we have 4 is equal to x minus 3 quantity squared. And to undo the square, we're going to take the square root. Don't forget your plus and minus. So we have plus and minus 2 is equal to x minus 3. And just like with the absolute value equations, we got to set this up into 2 equations. So 2 equals x minus 3, or negative 2 equals x minus 3. And so that's going to give us our x-intercepts at 5 and or at x equals 1, and we already found that. Now to find the y-intercept, that's going to be a little bit easier. So when finding the y-intercept, that means we're going to be on the y-axis here, so all the x's are going to be 0. So if we're looking for the y-intercept, the x is always going to be equal to 0, and there's only going to be one of them. Unlike the x-intercept, we can have multiple x-intercepts. For quadratics, it'll be a maximum of 2. But Y-intercept you only have one because the parabola is a function. So we're going to plug 0 into our formula, and just like what we did to find our points on our table down here, we could do the same thing. So plug 0 into our formula. Okay, 0 minus 3 is negative 3. Then we'll go ahead and square that, and that's going to give us 9. 9 minus 4 is going to be 5. So our input was 0, and our output was 5. So that's going to give us a point at 0, 5. And because of this thing is symmetric, we're going to also have a corresponding partner over on the other side. And then the last thing we'll do is we'll draw our parabola. And, we did the best we could to make it a nice, smooth, differentiable curve. So we'll try to make it a little bit more smoothed out here. Okay. I'm going to do one more example with where it's opening down. So just hold on for a moment. Alright, we're going to grab one more, and we notice that this one has a negative in front of the quantity squared, so that's going to tell us that this is going to open down, and we're going to have a maximum at our vertex. Our vertex is always going to be h comma k. H is always going to be the opposite of the number that's with the x, so it's going to be negative 5, and then the k is always the same, so negative 5 comma 7. So we'll go ahead and construct our xy plane, and then we'll put in our vertex. And I realize I forgot my negative signs on all the on the x-axis. Well, I'll put them in a minute. Our axis of symmetry is negative 5, so go ahead and put that in. We plotted our vertex, and we're going to go ahead and construct our table around our vertex, and we're going to plug in negative 6 and negative 4, and now I'm putting my negatives in. So oops, forgot that. Alright, so when we plug negative 6 in, it's going to be negative 6 plus 5, quantity squared, don't forget the minus sign on the outside, plus 7. So we do the stuff in the interior, negatives on the outside, negative, and then negative 1 squared plus 7. So we square first, and we don't square the negative on the outside, so that result is negative 1 plus 7. That's going to give us 6. Okay, now if we play the same game, we plug in negative 4, we'd have 4 here, then we'd have 1 here, and then we'd still end up with negative 1 there, and that's why we like to do it this way, because we really only need to do find the vertex and then 2 or 3 other points. I think I'm doing a little bit less maybe than what I've done in class because the limited real estate on the iPad. Okay, and we're going to pick one more. Well, maybe we did do 5 points, so this is the same amount we did in class. Alright, and this time we'll plug in negative 7 and negative 3, and we'll do negative 3. So negative 3 plus 5, quantity squared, plus 7. Okay, so it's equals negative, and then it's going to be 2 squared, plus 7. We'll square first, so we get negative 4 plus 7. And what we have left is 3. Now if we plug in negative 7, so if we plug in negative 7 here, then the result here would be a negative 2. And we would square negative 2 first, and we get negative 4, and we come out with the same outcome. Okay. Let's go ahead and get the Y-intercept also, and we'll plot those 2 points. The Y-intercept is going to be like way down below your computer screen or your phone, so you're not going to be able to plot this one. But we're going to go ahead and find it anyways, just so we can go ahead and say we have it. So we plug that in, and we're going to get a Y-intercept of 0 and negative 18. Alright, let's go ahead and connect our dots here. And I'm not sure where the X-intercepts are going to be on this one. We'll go ahead and find those in a minute here. Let's also mention that the domain for any type of quadratic is going to be all real numbers. The range is, the lowest it gets all the way down here to minus infinity. So it's minus infinity, so it's low to high. And the tallest it gets is 7. Okay, so we'll do another slide here in just a moment, and we'll find the X-intercept. Alright, so when we want to find the X-intercept, that means the Y is equal to 0. So we're going to go ahead and solve this equation here, and it's set up so that we could do the square root method. So we're going to isolate the square, so we're going to subtract 7 from both sides, and then we're going to go ahead and divide both sides by negative 1 to get rid of the negative sign in front of the x plus 5 squared, and then we'll take the square root. So divide both sides by negative 1. And then when you take the square root, don't forget that plus and minus. It's an easy points to miss on a test. Okay, and this one's not going to be very nice because we don't know what the square root of 7 is. So we're going to get plus or minus the square root of 7 is equal to x plus 5. You'll have two equations, but in both instances you'll subtract 5 and you won't be able to combine it with the plus or minus square root of 7. So using our calculator, we do negative 5 minus square root of 7, and that's going to give us about negative 7.6, and then the y-coordinate is 0. And then the negative 5 plus square root of 7 will be about 2.4, and then the y-coordinate was 0. So I don't think I did the best job. I think I went a little bit past negative 8 and a little bit to the right of negative 2, because I didn't know until now. So now I'd have a better idea, and my graph would have been a little bit more accurate. But that's finding your x-intercepts, finding the y-intercepts, finding the domain, the range, the vertex, graphing those things. So it takes a little bit of practice, but there are a bunch of easy steps that you already know how to do.